So it seems these days everyone is talking about agents with the new release of Codex. And I jumped into the code to see how it works. And I came up with this diagram that illustrates the flow of AI agents. So basically, it's not that complicated, really. It's just a back and forth communication between the agent or the program and the LLM, which does all of the heavy lifting. So everything starts with a user interaction that's here. And after the user makes a request, it sends it to the agent. And then the agent sends that same request to the LLM, but with an additional context of all of the tools that the agent supports. For example, it gives notice to the LLM that it can read files or write files or list contents in a directory, grab some files from the system, etc. And then it sends it to the LLM. The LLM processes the request and returns another message to the agent. And that message can either include tools that the LLM wants the agent to call for the LLM, or a simple message that it can emit to the user. If the LLM just ends the request with a simple message, the loop will end between the agent and the LLM, and it will emit the message to the UI or to the user, and it will await for further input from the user. Or if the agent has tools to process from the LLM, it will run those tools. And if either they succeed or fail, the agent will attach those results into the context window of the LLM and send the message back to the LLM. And it's going to be a loop back and forth between the agent and the LLM. Let's start some basic flow so that I can illustrate a bit more of how this works under the hood. I created a Rust project that's basically just some boilerplate. We are just importing a crate that's called Async OpenAI. That's an SDK for OpenAI, so we don't have to use HTTP calls. The env logger, it's just gonna log things. And anyhow, it's to manage errors. We also need to add Tokyo for asynchronous stuff. And we are instantiating the OpenAI client that's going to read the environment variables, and it's going to look for the OpenAI API key, which we are sourcing here. And let's start introspecting into this OpenAI SDK. So we can do OpenAI and chat, which is the endpoint that we're going to call. And let's create a new chat. This new chat, it's going to take a create chat completion request, and it's going to return a future so that we can await it. And let's do a to-do here for now, and let's await, and let's see the result. The result is going to be, if we look here, if there's an error, let's just bubble it up. So if we have a response, we are going to have the choices. And in these choices, this is going to be an array. Let's look into the choices array. There's going to be messages. And inside the messages, on the first choice, we're going to have either tool calls that the LLM is calling, or just plain content so that we're going to display to the user. And let's see how we can instantiate this chat completion request. So let's go to definition, and let's see the type of this create chat completion request. We can instantiate this by doing a create chat completion request args, and that's a builder, and we can attach messages and the model that we want to work with. It has a bunch of options that we can override. So let's do this. It's going to be the chat completion request args, and let's create a variable called request and do create chat completion request args. Let's import this and the default options. Do a build here. We need to handle the error. So let's override the, for example, the model. Let's do GPT-4o, and then let's create this is going to be very important, the messages. For now, let's just insert an empty vector, and the tools that we are going to support, let's insert an empty vector for now. Now let's go into the tools. So for now, let's just create an empty, like a tool that can read a file from the file system. Let's go to OpenAI platform. And if we go here to the playground and we go here to functions, it gives us a description of how the tools look like. So we can just copy this out and adapt this template to our tool that we're going to call. So we need chat completion tool, right? We're going to create, let's go to tools, and we need a chat completion tool args builder. So let's create the chat completion tool args. Let's define here a variable called tools, and this is going to be a vector of the chat completion tool args, chat completion tool args here. And let's do default. Okay. And we can probably, no. So let's see how we can fix this. Chat completion tool. Oh, it's here, sorry. Chat completion tool. Chat completion tool. Maybe we can construct this just like this. Chat completion tool. And here insert the values. Yeah, we can do this. And for the function, this is a function object and function object. Okay. The name, this is going to be, let's say, read file to string. The description, let's do read a file from the local file system to string. What's here? Description. Oh, okay. So this is going to be a sum. Let's wrap this here. Parameters option value. Okay. So the parameters, let's wrap this in sum, and this is how we construct a value, which is just a JSON. And this is where this comes into play. So we can just copy everything, paste it, go into the parameters and paste this. And let's just paste this again. It should be working. And let's just comment this out. Yeah, now it works. So we only need one parameter, and it's going to be, instead of location, we can just do a file name. And it's going to be the name of the file to read. And this is going to be, we don't need two parameters. And here we only require one parameter. This is going to be strict. Wrap it into a sum, and we can get rid of this. We can pass the tool here. The tools, sorry. We can do, let's see now how we can construct the messages so that we can start to call the API. And messages are type chat completion request message. And if we go here, chat completion request message. So we're gonna need now a user message as if we're the user, and chat completion request user message args. Let's see, chat completion request user message args default. This is going to be a result, and we can add another override with content. So let's do what is source main about. Summarize it in one sentence. And we can add here the message. And gonna yell because it needs another type, but we can just do into to transform the type. And after this, let's just print the request and run the program and see what happens. Okay, so we get, yes, the important part is here. The LLM is making a call, tool calls, that he's calling a function that the name is read file, and the arguments are, for the file name, they are source main.rs. So now we just need to respond to the LLM. So in here, instead of printing, we can just enter into a loop and do, for example, let the response, it's gonna be response choices, and let's do the first choice. Let's unwrap, you know what, let's add some context here. If there's no choices, let's handle the error and let's clone so that we have an owned value. And here we get the chat choice. If we go to the chat choice, we have the messages, which are the important thing. As a matter of fact, we can just do message and we get the chat completion message. And we're going to have all of the tool calls that the LLM is calling, or the content. Let's do match, and let's say the rest dot tool calls and the rest dot content. And let's create here an underscore so that we don't get more errors. So this is the part where we get tool calls. And let's handle the case where we don't get tool calls, but we get content. So in this case, we can just print the content and break out of the loop because there's nothing more to do. And in the case where there are tool calls, we have to process the tool calls, right? So here we just need to process the tool calls so that we can attach the result of those tool calls and send it back to the LLM. So for example, yeah, this works for tool in tool call, and we're just iterating over the tool calls. And if we inspect this tool call, we're going to have an ID of the tool call, the type, and the function call. So in the function call are the name and the arguments. Let's just parse the arguments. Let args is going to be tool call dot function dot arguments. And let's parse this as assert the value. And again, let's just propagate the error upwards. And then we have the function name. It's going to be tool call function name. So we can do let's use Tokyo read to string. And then for the path, let's use args here, and we can pass it's going to be file name. This returns an option, so let's just wrap. And this is going to be the contents of the file. We can just, no, this is not good. So we need to do toString. Try as ref path not implemented for value. Okay, so this is a value. So we can do as str on wrap. Okay, let's do it here. File name is equal to file name. Yeah, for some reason, I don't know why. But we should have the contents here of the file. And now we can just append this to our messages. So instead of having the messages directly in here, we can do let mute messages, put this into a vector, and just clone the messages. So now we have to append new messages every time into here. In the first call, we just clone everything. But now in here, we just have to append messages, push, and we have to push going to be a tool call message. So if we go here, we have to append this enum variant. So let's see, we can create it with chat completion request tool message args. Chat completion request tool message args, and it's going to be default build, and that was, I think, into no. And again, let's just create it here. Let message, it's gonna be equal to, okay. It was because of the result. So let's push the message and into, and here we can override the values. Let's see, we can do content, and this is going to be chat completion request tool message args. It's quite annoying to start to go back and forth, but it's okay. Chat completion, can we do this right now? No. Chat completion request tool message content. Chat completion request tool message. Chat completion request tool message. Then, you know what we can actually do? Just construct it. Chat completion. And for the tool call ID, we have to specify what was the tool call ID. So we can just do tool call ID so that the LLM can know what was the tool call. And for the content, it's going to be chat completion request tool message content. For this, if I'm not mistaken, we can do into. Yes. So instead of an empty string, we just insert the contents and do an into. And yeah, now we're gonna append the tool call, but we also have to append the previous tool call. So for that, we have two messages push, and then we have to, let's see, I'm not sure what was the, it's going to be create chat. Okay, this one, it's going to be an assistant. I don't know. Require chat completion request assistant. Okay, so let's do this for now and see if it works. Let's create the assistant message equals to this. And content refusal, no, solution. Okay, so let's use the builder here and add content tools or function called tools. Okay. So we have to, let's do function call, chat completion request message args. And this is going to be function args type function call name. Okay, we can do this, but let's clone it so we don't have issues. And here, let's just append this message push, and we're gonna the assistant message into. Great. Okay, so we're handling the case where we have a tool call and content here. If we have content, what are we doing with the content? We're not doing anything. So if we have the content, we can just print it. And we have another case where, okay, so what if we have a tool call but no content? So let's just create here this case instead, and maybe content. And here we can do if let some content equals maybe content print. Yeah, but we're not gonna break. We're just gonna print this out and process the tool call. And then after we process the tool call, we can just create a new chat and send it. You know what? We can make this mutable and we just have to send it over again and again. So where should we do this? I think we can do it here. Okay, we're just here. Tool. Yes, we need to clone them here too. And we send a request again, but we need to update here this request. So we can do, yes, like this. Expected chat completion response message. Found create chat completion response. An AI chat request. Oh, because we're shadowing here the response. So let's go with first choice. Yeah, I think this is it. Okay. I think this works. Let's run it. Invalid parameter with role tool must be a response to preceding message with tool calls. With tool calls. Tool calls. It's gonna be type to a chat completion message tool call. Can we insert the back just like this? Yes. Chat completion request. Chat completion request message tool call. Let's do this. Import it. Okay. ID. Tool call ID. Yes. And the function call. I think we have this in tool call function. Yeah. Let's clone. And let's clone this as well. Let's run this. Okay, it works. It gives back the summary of source main. The source main file is a ROS program that utilizes OpenAI for chat completion, allowing it to read and summarize blah, blah, blah. Perfect. So obviously this is just a playground. This is not how it would scale, but you can see how you can just start to add parts into this just by adding the tools. And on every iteration, the LLM will decide which tools to call, and you will just execute the tools, respond with a success or with an error, and then the LLM will try to call back the tools and correct how it's calling the tools. And instead of doing this manually, you will have another form of input, be it a CLI tool or a VS Code or whatever program you're trying to use. In this part where we match for the choices, like we can just, if the LLM responds with some context, we can just pretty print the context to the user so that he knows what's going on. This is honestly more than anything like an engineering kind of problem, because you rely on the LLM for everything. You just have to manually check and make sure you parse the arguments, make sure if the LLM gives you something that, for example, in a div, you need to check that the div is correct so that you can apply the div and modify the system prompt of the LLM so that you can tell how to respond back in what format you want the data. And this is just one tool, read file from the file system, but you can have as many tools as you like. Execute commands raw for the CLI so that you can just pass them directly, or write to files, or I don't know, whatever. You can use your imagination here. But yeah, this is how it works. And like if somebody is it seems like everything is magic, but it's not. Like this is just how it works. Yeah. Peace, guys. Bye.